We derive the formula to find the energy emitted from an object with constant temperatures. We can apply this formula to ourselves. Our body temperature is kept to be a nearly constant value 37 degrees or 36 degrees Celsius. The energy is required to maintain the constant temperatures because we emit the energies into the space like a stars. Our body temperature is kept is 36 to the 37 degree. The required energy is called the basal metabolic rate. Basal metabolic rate is given by the 2.2 kilocalorie per kilogram per day. The basal metabolic rate for a man with 80 kilograms can be calculated by multiplying the 80. So 2.2 times 80 equal 1760 kilocalorie per day. Maybe you might have heard these numbers. I would like you to derive these numbers using the knowledge we learned. Before solving the questions, we need to review the Stefan-Boltzmann laws. That is, the energy flux from the surface of an object with a temperature T per unit area is proportional to the force power of the temperatures. So if we consider the object with a temperature of the constant temperature of T, the energy is emitted from this object. And if we consider the unit areas, amount of the energy emitted from these unit areas can be calculated, sigma T to the fourth. This is Stefan-Boltzmann law. So sigma is constant values. 5.67 times 10 to minus 8 watt per square meters Kelvin to the fourth. So we can use this law to estimate the basal metabolic rate. We use the Stefan-Boltzmann law to derive the basal metabolic rate. At first, we need to convert the unit of the temperatures from degree to Kelvin. Our body temperature is 36.5 degrees Celsius, which is equal to the converted kelvins. You have to sum with 273.15 plus 36.5 to convert from the degree to the Kelvin. So it becomes 309.65 Kelvin. So we could convert the temperatures from the degree Celsius to the Kelvin. The surface area of a man's body is simply estimated. So if we consider the height of the man is 1.7 meters. Then surface areas or the width of the man's. Simply we make a really simple assumptions. Width is 0.35 meters. So this is 35 centimeters. You can imagine that this might be the good ones. And the surface areas of a man's can be calculated. Area is a height 1.7 meters times 0.35 meters times 2. Why? We have a front and back. So front side and back side. You have to take into account the both sides. Then it becomes 1.2 square meter. This is surface area of the lens. Assume the temperature outside of our body is 26.5 degrees. So in these cases, we consider our body temperature is 36.5 degrees. It's emitted the energies. Then too much energy is required to maintain our body temperatures if our body is placed in space. But fortunately, our body is surrounded by the airs. Air is also give us the energy because air is also the emitted energies. Air temperatures is assumed is 26.5 degrees. It's a little bit higher, but lower than our body temperatures. This is 10 Kelvin lower than our bodies. So our body does not absorb the whole energy from the outside because our skin color is not perfect black. It is sufficient to assume that about 90% of the energy is absorbed by our bodies. One day, so also we need information of the one day. Convert a day to the second. So 24 hours times 3600. This is 1 hour is equal to 3600 seconds. So it becomes 86400 seconds. So we could convert the day to the second. Finally, we can calculate the basal metabolic rate. So this is basal metabolic rate. Is calculated E, total amount of energy, required energy to maintain our body temperatures, equals sigma T body to the 4. This is the emitted energy from our bodies, minus T to the airs. This is the temperature of the airs. We received this energy from the airs. And this is epsilon. We have to multiply the epsilon. And S is the surface areas times delta T is 1 day. This is 1 day. This is surface area. This is how much energy can be absorbed by our bodies. So our color skin is not perfect black. So about 90% of the light is absorbed. So you can substitute all the information into these equations. Then you can find out. And also you need to convert from the joule to the calories. It becomes 1400 kilocalorie. This is a bit smaller than the actual basal metabolic rate. We have already shown you that this basal metabolic rate is given about 1800 kilocalorie. So this is a little bit smaller than the 1800 kilocalories. But we almost get the similar values of the basal metabolic rate. Because of the simplifications we adopted in these calculations. Okay, so this is it. This is the answer to this practice.